So next up we have the binary search of an array. Now, I really am unconcerned if the quantum leap it takes between simple math and kind of that calculus looking piece you see in the book in 7.3 when we're doing the linear and the binary search of the array. But this is what the takeaway from 7.3 is. What I will tell you is it looks complicated. And it's actually one of the reasons I split up this chapter into two separate sessions is because later on in everybody's career, whether or not you really genuinely work with data on a day in and day out basis, that's kind of immaterial. Sooner or later in everybody's career, it's going to become important that we know how or why it is we want to search or sort our data. And at the very, very core of that, there are essentially three key pieces. The linear search, the binary search, that's the one this video is going to cover, and the bubble or the select sort, which the next video will cover. And each of those has this kind of like weighty looking, really scary, n minus 1 equals n plus 1 divided by 2 over, and it's crazy looking, but at the end of the day, it really is not that bad. So a binary search is as follows. We've already established that we can go all the way through all of the 26 letters in our alphabet, and we can go all the way through the 171,000 individual entries that are in the English dictionary. But that potentially could take a very, very long time, right? If I've got a word in the second half of the dictionary, right? So M, I think everybody is comfortable with being the middle point of our dictionary. Now, is it exactly the middle? Maybe not, right? Because we've got some letters are going to be more densely populated than others, and it's just going to be the way that goes. So some letters, S, for example, are going to be really densely populated. Other letters, the Z, for example, are not going to be particularly densely populated. So roughly speaking, M is the middle point, and I'm pretty happy to just kind of squint at that problem until all the gray areas go away. So let's suppose we're looking for a word in the second half of the dictionary. So let's just go to S. We'll pick a random one down here on page 10 of S. We're going to look for Schatzi, because that's a really good German word for whatever. It's a pet name. Schatzi. It's also a very good name for like a wiener dog, I think. Okay, so we are looking for Schatzi, and that's here on page 10 of the S's. Now, this particular page is going to be hundreds of pages. This is going to be tens of thousands of entries into our, total of 171,000 words in the dictionary. So we need to do better than getting here, hundreds or potentially 100,000+ words deep. So we need the binary search. The reason it's called binary is for every essentially flip through our search, for every time we get to the top of a do while loop, we are eliminating 50%, half. That's why it's binary. So 50-50. We are eliminating 50% of all the remaining values. So the first one, the first loop through, this is what we do. We set a low number, and that's going to be a low letter. That's going to be A. Then we set a high letter, and that's going to be Z. We take that and we divide it by 2, and we get M. Now, ask yourself, this is what you do mentally, but we just have to get a piece of math for this. What is the value of S? Is it greater than or is it less than M? So we know that S is greater than M, right? So that means I can eliminate every letter to the left-hand side of M. So I can eliminate mathematically everything less than M. So now M, excuse me, M becomes my high letter, or excuse me, my low letter, and Z becomes the high letter. What's halfway between M and Z? It's in between R and S. So we'll pick S. Now we go, what's halfway? So already I've eliminated 75% or more of the alphabet. And now I can just do my loops right here inside of this. Is it greater than or less than S? We're going to come back over here to W. Is it greater than or less than this? We're going to come back here to T. Is it greater than or less than this? And we're going to come back to S. Sooner or later, we're going to come down and we're going to settle on essentially two words. And I'll show you what that looks like in just a second. And it's going to be between Shotzi and Shotzen, right on top of it. And sooner or later, that is going to match one for the other. So the binary search looks like this. We've got 171,000 words in the dictionary. I divide that by 2. I now have 85,000 records to sort through. The next time I divide that by 2, 42,000 records to sort through. We're getting there fast. Divide by 2, 21,000. Divide by 2, 10. And if we keep going, you'll see how quickly it is we really start closing in here on our answer. This time it's 1.3. For one more sake, we'll go here to, 0.65. That means for sure by now, worst case scenario, we have located the word that we are looking for. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That means that for no word in the dictionary is it possible that it is greater than 17 searches through the dictionary. We have eliminated hundreds of thousands of individual linear searches by doing a binary search. So that's really all the binary means. We take a high, we take a low, we divide by 2. We reevaluate. Is it less than or is it greater than? If it's greater than, the middle point becomes my low number, and then I divide it by 2 from my high number. I check again, and then I do the exact same operation every time. And every time we do that, we are relieving ourselves of having to look through, potentially billions of records. So think about that. If we do that with Facebook, the first time through we have 3 billion records. The second time through we have 1 billion records. The third time through 500,000, 250,000, 125,000. Look at how quickly it is we start to eliminate huge swatches of data. The binary search is a tremendous tool for us to take a vast amount of data and in super short order eliminate everything that's not the value it is that we're looking for. So the binary search is a tremendous tool in our data operations arsenal.